Okay, let's see, for you, Thursday, and we have tests on Monday, and we last saw a little bit of a video segment. If you drop a hammer or feather in a vacuum, and the moon's a vacuum, they'll fall together at the same rate. Now, the moon has gravity, but it doesn't have air, so it's a vacuum. It just has about 1/6 of the gravity of Earth, so it's quite a bit less. Helium balloon wouldn't have anything to float in, it would fall with them. Okay, we are on page 66. Use vocabulary, number 31, speed and velocity. They want you to talk about those two. They want you to compare and contrast them. While they're both distance over time, you're aware of what something's speed is. The difference for velocity is velocity has an assigned direction. So they both tell you how the distance changes over time, and they indicate how fast something is going, but velocity includes direction. So you should have done this work in class on Wednesday. What I've seen so far, people have. You should be correcting it right now. Hopefully it's available through Edpuzzle and Google Classroom. They were not getting along earlier this week. This time I don't think it was me. Number 32, what's the difference between motion and displacement? Well, motion occurs, you know what motion is. An object's moving against some reference point. They're moving in relationship to a reference point. So it occurs when the object changes position. Displacement describes the distance and direction from a starting point. So displacement is distance and direction from a starting point. We discussed that with running around a track. You could go across the field, and then that'd be a shorter distance and direction. That'd be a velocity. Good velocity if you did it over a time. Okay, next, velocity and momentum. Well, momentum is a math equation, mass times velocity. So you're going to multiply velocity times mass to give you momentum. So velocity is speed and direction. Momentum is velocity times mass. Both of these can be used to describe an object's motion, but you're probably going to use velocity or speed for the object's motion. Acceleration and velocity. This is confused a lot, even by physics students at the beginning. Velocity, speed, and direction again. Acceleration is how fast the velocity changes over time. And if you go in a straight line, we have an equation for that. There's lots of equations for acceleration. We are only using this one. By the way, delta t just means time change. This could be time final minus time initial, or time 0. So you have an equation for that. So you put the velocity change over the time change and you get acceleration. It's the only equation you have for acceleration at this time. Not what I wanted at all. Okay. Houston, we have a malfunction. Okay. See if I can get this back up. Next question was 33. Which of the following you calculate when you divide total distance by total travel time? And that is average velocity. C. Oh, 35 is A, average speed. Okay, I said velocity. That's true if you got direction assigned to it. In this book, total distance over total times average speed. Total displacement over total time is average velocity. We're not doing that one. We're doing speed. 36, which one is the SI unit of acceleration or metric? It's meters per second squared. C. Which of the following is not used to calculate acceleration? Well, we had both velocities at both times. So we aren't using average speed. We've got the starting speed, the ending speed, the starting time, the ending time. Those 4 things. A car, a bicycle, a mouse, and a bug have the same velocity. Which has the greatest momentum? Well, the one that's most massive. So that is A, which is the car. 39, in which of the following conditions does the car not accelerate? You can't change any direction or speed if you don't have an acceleration. So it's the answer where there's not a direction change and there's not a speed change, which is A, car moves at 80 kilometers on a flat, straight highway. All the other ones, there's a force involved in turning or speeding up and slowing down. 40, how is speed defined? Total or distance over time. Average speed is total distance over total time. Which best describes why projectiles move in a curved path? 41, I want to talk about a little bit here. Why is because, let's say you're an airplane dropping a bomb. That bomb is going to, in a curve. The airplane's going to fly directly above it. 5 seconds after it drops it, the airplane's still right over top of it. The bombardier can see that just like we could watch Felix going off in the distance, that bombardier could watch that bomb go off in that distance, right down the bomb site. And that bomb would fall if it flew by a really tall tower and knocked a tower guy off. At the same time a bomb dropped out, they would fall together. Except for the person probably has slowed by air resistance more than a bomb would be. So this happens together, and it stays right over the airplane. So the reason why is because the velocity in the X direction is constant. It stays what it is. The velocity in the Y direction is getting faster and faster and faster and faster. It's accelerating. And those two motions are independent of one another. One doesn't affect the other. So the answer is A. You have constant horizontal velocity and vertical acceleration. The next one, number 42, I want to take a look at. What you should have had, if you plot this, put distance on this side, time on this side. I didn't look to see what the results are, but I know how students are graphing. They're probably sketchy, so you need to improve this probably, so you should be working on this right now. We're going to put dots in here. We don't connect the dots because we didn't measure anything between the dots. We don't know for sure what's going on with that. But I'm going to put the dots on the next page. And if you plot this, it looks like this. At 0 seconds, Sally's at 0, 2, 4, 6, 8. Alonzo at 1, 2, 3, 4 seconds goes up 1, 2, stays at 2, and then goes to 4. So if I put lines in there, don't you do that, by the way. I'm just doing this so you can see it. All right, it says, what is the average speed of each runner? So average speed is total distance divided by the total time. And the way you do that, which you probably didn't do right on your paper just due to lack of experience, is the total compared to the start and the total compared to the start. And the other ones aren't affecting the average. And if you work it out for those two, Sally's going 8 meters in 4 seconds, which is 2 meters per second. Alonzo is going 4 meters in 4 seconds, which is 1 meter per second. Neither one of them is going very fast. I don't know why they call them runners here. Over what time interval do they have the same speed? The speed here looks like it's 2 meters divided by 1 second, or 2 meters per second for both of them. Here his speed is less because the slope is less. Here his, well, he is stopped actually because he's at the same distance of 2 meters. And there his speed matches Sally's. Okay, concept map. and then I'll go to another video. Whoops. By the way, remember I was saying those are both 2. They went up 2 meters in 1 second, 2 meters in 1 second. They're both 2 meters per second. Okay, motion can be described by what, and what. See, change in velocity over time is acceleration. Change in position is motion. I think that's motion. Velocity includes distance and direction. Well, velocity includes speed and direction. This is direction. That's got to be speed because speed is distance over time. Okay, next video.